In Lesson 1-2, we're studying order of operations. You'll learn to evaluate numerical expressions by using order of operations and evaluate algebraic expressions by using order of operations. I think this problem may be outdated, but it's still interesting to look at. Nicole is signing up with a new internet service provider. The service costs $4.95 a month, which includes 100 hours of access. If she is online for more than 100 hours, she must pay an additional 99 cents per hour. Suppose Nicole is online for 117 hours the first month. The expression $4.95 plus 99 cents times 117 minus 100 represents what Nicole must pay for the month. Numerical expressions often contain more than one operation. A rule is needed to let you know which operation to perform first. This rule is called order of operations. First step, we need to evaluate the expressions inside the grouping symbols, which those are usually parentheses or braces or brackets. Evaluate all powers, those are exponents. Do all multiplication and or division problems in order as they come to you from left to right, because that's the way we read in English. And then do all additions and or subtractions in order as you come to them from left to right. The acronym that's often used for this is PEMDAS. I learned it as Please Excuse My Dear Aunt Sally, but now they just shortened it to say PEMDAS. This expression doesn't have any parentheses or exponents, so we get to look first for our multiplication division. Okay, and I do have one multiplication. I have 2 times 3. And then I'll do addition and subtraction moving from left to right. So I'm just going to copy down the 6 plus 4 for now, because that's an addition, minus I have to do any multiplication and division first, so 2 times 3 is 6. Now I can just move from left to right. So 6 plus 4 is 10, minus 6 is 4. Again, this expression doesn't have any grouping symbols, so I don't need to worry about parentheses. I do have an exponent, so let's get that done first. So I have 48 divided by 2 cubed is 8 times 3 plus 5. Okay, now the exponent's taken care of. I'm going to look for any multiplication division moving from left to right. And I've got one nice long chain there of multiplication and division. So I need to do that next. So 48 divided by 8 is 6 times 3 plus 5. Sorry, my 6 looks like to be 6 times 3 is 18 plus 5. And then finally we get to do our addition and subtraction moving from left to right. Oh, that's all we have is one addition, so I guess it doesn't matter. It's 23. The next example adds grouping symbols, which actually makes it easier. Using my absolutely awesome powers of observation, I can see I have 2 sets of parentheses. So I'm going to do that first. 8 minus 3 is 5. Aha! I don't know why we have a center dot there because it's kind of redundant, but I'll copy down anyway. 3 plus 2 is also 5. Okay, so parentheses, check. Exponents, no, I don't have any. Multiplication, yes, I do. So let's do our multiplication moving from, multiplication, we could use the commutative property, so we don't actually have to move from left to right, but yeah, actually, I think I'm going to use the commutative property and switch it up. 5 times 5 is 25 times 3. Commutative property, we can switch the order any which way it's convenient for us. 25 times 3 is 75. If I'd multiplied 5 times 3 is 15, times 5 I would also get 75, but you know, we're used to quarters, so 25 times 3 is a common mental math. When more than one grouping symbol is used, so in this one we have both brackets and parentheses, start evaluating within the innermost grouping symbols. Okay. Not a problem. They told me exactly what to do. So I'm just going to copy down 4 times 12 divided by, inside the innermost grouping symbol, inside that parenthesis, I have 6 minus 2 is 4. Okay, so I'm still in P mode because I'm getting rid of my grouping symbols. So I need to evaluate inside those grouping symbols before I can multiply. So 12 divided by 4 is 3. Okay, I need to take care of that exponent yet before I can multiply. I just need a number to multiply by. So 3 squared is 9. And finally, 4 times 9 is 36. As we continue on here, life gets getting better and better because next we get to use a fraction bar, which simplifies life more yet. Okay, the first grouping symbol, the only grouping symbol we have is the fraction bar, which means divide. So I need to simplify everything in the numerator, then everything in the denominator before I can divide. So I'm in parenthesis mode, but to do that I need to work with exponents first. So 2 to the 5th, let's see, 2 times 2 is 4, 4 times 4 is 16, times 2 is 32, minus 6 times 2 is 12. Now you wouldn't have to write that out, I just did that mentally, so I thought maybe I should write it out. Okay, 3 cubed is 3 times 3 is 9, times 3 is 27, minus 5 times 3 is 15, minus 2. We're still in P mode. So 32 minus 12 is 20. That's good. 27 minus 15. Okay, now we're working in order from left to right. Okay, so 12 minus 2 then is 10. And finally, 20 divided by 10 is 2. They want us to evaluate, so every place there's an x, I need to substitute in what x is equal to, which is 4 this time. Every place there's a y is supposed to be 3. And every place there's a z, I'm going to replace z with a 2. And then we're going to use PEMDAS. So inside our parentheses, we're going to have, well, now we're doing exponent mode. 4 squared is 16. Copy down the minus 3. And 2 squared is 4. So I just went through and caught all my exponents. That was nice. Goodbye, exponents. But I still have parentheses I have to get rid of. 16 minus 3 is 13. And 2 times 3 is 26. Haha, we just finally completely got rid of parentheses. Now no multiplication division left. We already got all that done using getting rid of our parentheses. And addition, we get 26 plus 4 is 30. We're having so much fun, we're going to wrap this up with a word problem, our favorite topic of all time. Each of the 4 sides of the Great Pyramid at Giza, Egypt is a triangle. Make a picture whenever you can is a good idea. The base of each triangle originally measured 230 meters. And the height of each triangle originally measured 187 meters. The area of any triangle is 1/2 the product of the base b and the height h. Write an expression that represents the area of one side of the Great Pyramid. Okay, well, all they want for this is the general expression. So they said the area of any triangle, which this is 1/2 the product of the length of the base b and the height h. All of those words, and that's all they needed for that. Now, when I just wrote mine, for of, I didn't even make a center dot. I just wrote it all together, 1/2 BH. But you could have used center dots. This is an option. So the really interesting thing comes when we evaluate. So 1/2, B they said was 230, and H was 187, and they were both meters. And when we grab a calculator, 1/2 times 230 times 187 is 21,505. That's an ugly 5. And meters times meters, meters just use the factor twice, so it is meters squared for our label for area. So in summary, when simplifying with order of operations, We want to start with grouping symbols, evaluate all powers, do all multiplications and or divisions from left to right, and then do all additions and or subtractions in order from left to right. PEMDAS.